Hi guys, welcome back to Octet Sci Academy. Today we're going to be looking at an important scientific concept. It is something that we use a lot in our day-to-day activities, and it is everywhere around us. We're going to be discussing the concept of matter. We're going to be looking at what matter is, the properties of matter, the various forms in which matter can exist, the properties of these various forms in which matter can exist, and how they can be changed or converted from one form to the other. Please like, share, and subscribe. Now let's delve right into it. So what is matter? Matter is anything that has mass and can take up space. So basically, matter is anything that has the ability to take up space and has a mass. So it exists in various states. For example, this pen is an example of matter, because if we put this on a scale, we're able to get a weight for it, and obviously it takes up space. We can literally measure how much space it takes up. So matter is anything that has a mass and takes up space. Matter is composed of various elements and compounds. For example, my pen is made up of polymeric materials. The water we drink is made up of hydrogen and oxygen elements. My glasses could. What are the states in which matter can exist? Matter, as it is, can exist in 3 different states. Matter can exist as a solid. For example, this pen will be classified as a solid. It can also exist as a liquid. For example, water, drinking water, and it can also exist as a gas. Example again, the air we breathe in. Those are the main 3 classes in which matter exists: solid, liquid, and in gaseous state. So what is matter? So let's look at each of these states of matter one after the other and what differentiates a solid. Again, this is an example of a solid material. Your writing desk or your writing table is also another example of a solid material. And mere examining a solid material, you realize that solid materials are rigid. It is almost impossible for me to change the shape or the form of this pen without using any other external force. So their shapes are fixed. I can't alter the shape of this pen without using something very, very powerful. The volume is also fixed. I can't reduce this volume. If I squeeze it, I can't compress it. So it can't be compressed and it doesn't flow. So unlike liquid, where you can have layers of it sliding over one another. So solids are tightly packed. And because they are so tightly packed, the molecules that make up solids are tightly packed. That is why they are very rigid. The shape is fixed. They usually fixed, and you can't compress it because they are held together strongly by different forces that makes the component to be very, very tightly packed. The most you can get out of a solid is to make it vibrate in a position. So it cannot flow. You can't compress it. It has fixed volume, it has fixed shape, and it is rigid. A fun experiment for you. Go around your classroom or your house and identify 5 materials that are in their solid state and leave your answers in the comment section. The second state of matter that we're going to be looking at will be the liquid state of matter. It has no fixed shape. Liquids will take up the shape of whatever container they are in. If you are looking at this bottle of water, the water in this bottle has taken up the shape of this bottle. If I decant this water into a cup, for example, the water takes up the shape of the cup. And they do not have any fixed shape. Like I said, they are not rigid, because although they are closely packed together, they are not as tightly packed together as solid. So this allows for some form of flow. So you can see liquids are able to flow like water, like you can see here. You can slightly compress liquids, unlike solids that cannot be compressed at all. Liquids can be slightly compressed and they are able to slide and roll past one another, and and that is how and why they flow, because they're able to roll past one another. The third state of matter will be the gaseous state. They are widely spaced, they are not tightly packed in any way, and they are not strongly held together, unlike solid and liquids that are held together with a higher level of force. They are able to travel randomly, colliding with one another and with the walls of the container in which they are stored, and they move around really, really quickly. They are not rigid. They are able to move around quickly because they are not rigid, they are not held together strongly. They don't have a fixed shape, they do not have a fixed volume as well. Gases can be compressed and they are able to flow just like liquids as well. Properties of matter refers to their attributes or characteristics of how we're able to categorize and identify materials around us. In the world of science, materials, things, matter, are characterized based on physical traits and chemical traits, and these are called physical properties and chemical properties. So every material that scientists characterize or identify, they are able to categorize them based on their physical properties and their chemical properties. Physical properties, for example, are properties that are observed without changing the inherent nature of the material. For example, you can say, oh, this pen is pink in color. That's a physical property. We're not talking about the material, the type of atom, the type of bond that holds this pen, the type of bond that holds the compound that make this pen up. We're not talking about that. We're just like, okay, you can see it, you can observe it without inherently changing the nature of the material that makes up the pen itself. So you can say, oh, color is an example of a physical property. For example, we say water is colorless. We don't necessarily need to do anything. We don't need to do a chemical reaction to come to that conclusion. We don't need to change the components of water before we know water is colorless. So those are examples of physical properties. Chemical properties, on the other hand, describe how materials, how substances interact with one another. For example, if you add vinegar to baking powder, what happens there is a chemical properties, a chemical change, because you're now changing the inherent nature of the vinegar as well as that of the baking powder in that experiment. For example, when you expose slices of apple to air and you observe a discoloration, that is an enzymatic reaction going on there. You're changing the components, the behavior of that material by exposing that apple slice to air. So such a type of observation is called chemical property. Another type of physical property outside of color is texture. What does it feel like? Is it smooth to touch? Is it sticky? Is it slippery? Those are all physical properties. Like my notebook, what does it feel like? What does it feel like to touch? Those are all physical properties. Hardness, how hard is the material? Is it very hard? Is it brittle? How much of effort or energy is needed to break it, or otherwise? So is it transparent? Can light pass through it? You can see for all of these tests, you're not altering the material. You don't need to do anything to feel the texture of your book, right? You don't need to do anything to know whether, oh, can light pass through this pen or otherwise. So those are all physical properties. Now let's move to chemical properties. And one type of chemical property that scientists often use to classify characterize matter is flammability. That is the ability of a substance to ignite and burn in the presence of oxygen. When this happens, it produces heat and light. For example, if you're burning scented candles in your house, that is flammability. That the ability of the substance to actually ignite and continue to burn when there is a supply of oxygen, and then it produces light and heat, like when you burn your scented candle. This is a chemical change. This is a chemical property because you're forming new substance. For example, if you ignite a piece of paper, what you're going to end up with will be what? Ashes, and then you're going to have some heat giving off. You can't get back your paper that you started with, so you've changed the component, you've changed the inherent nature of that paper into ashes by subjecting it to burning or combustion. Another chemical property is also corrosion. If you expose a metal or iron is exposed to oxygen and water, we observe what is called rusting. So when the iron rusts, you can't get back the iron. Matter can be changed from one form to the other, and such changes are characterized again as either physical in nature or chemical. So we have physical changes and chemical changes. And as you might have guessed, physical changes will involve changes or conversion where you're only changing the physical properties. So if you're changing the color, you're changing the texture, you're not necessarily changing the chemical properties or the chemical fingerprint of the materials that make up the matter in question. Physical change involves change in physical properties such as shape, size, and state of matter when you're not necessarily changing the chemical composition. What are the things that characterize a physical change? You don't form a new substance with a physical change. For example, I've grabbed some ice cubes here. To change water at room temperature to these ice cubes, I just need to pop it in the freezer and then I'll get ice which is solid in nature, but it is still water. If we leave it long enough, it's going to actually dissolve into its liquid form. So nothing has technically changed. We've just frozen water. It is still, when we test for water, it is still going to be water, and we can literally just wait for it to melt into its liquid form. So you're not creating an entirely new material. So look at this piece of paper. If I continue to fold it now, fine, I've changed the way in which it exists from this something that looks like this to something that looks like this. But at the end of the day, they are still both what? Paper. So I'm not making a new material. So folding of a piece of paper is also another example of a physical change, because I am not making a new material out of it. I'm most likely just changing the shape, the appearance, or the texture. Other examples of physical change in changing from solid to liquid state, changing from liquid to solid state like we have seen here, changing the shape of a material. Like if I squeeze this piece of paper now, I've changed the shape from what I had previously, but at the end of the day, it is still a piece of paper. I'm able to get back the sheet I actually started with. Chemical changes, on the other hand, involve changes in the chemical composition of a substance, involving you now making new materials. If I set this piece of paper on fire, will I be able to get my piece of paper back in this form? No. What I will end up with will be ashes from the burning or combustion of this paper. I have succeeded in making a new material. So that is a chemical change, because I have made a new material. It is not reversible. I can't get my paper back. So I've made something. I've changed the chemical composition of my paper into that of ashes. This is the part that is usually asked in most O-level exams like WAEC, GCSE, and JAMB, that you should state the differences between chemical changes and physical changes. So this table is a nice summary of that. In physical changes, you're not forming new substances. Again, example with water at room temperature and ice. No new substances formed. Still water in both instances. Chemical changes, you're forming new materials. Example, combustion of paper. If I set this on fire now, I'm going to end up with ashes and no longer paper. So I formed a new material. In physical changes, the changes are reversible. It is easy for me to get my water back from these ice cubes. I'll just leave it at room temperature and it's going to melt and I'm going to have my water back. In chemical changes, they are irreversible. I can't get, if I set this on fire, I'm not going to be able to get my paper back. It's gone, it's done. Chemical changes changes chemical composition of the material. So the chemical composition of paper changes when it undergoes chemical changes by burning, and then it becomes ashes. Ashes and paper like this are have different chemical properties. Whereas in physical properties, there is no change in chemical composition. It's still water, it's still H2, it's still hydrogen and oxygen in these two sets of samples of water that we're using. Also, physical changes usually involve change in state. So, like we froze water to give us this ice cube, we've just changed the state from liquid to solid. Whereas in chemical changes, it does not necessarily, you're forming an entirely new material that would have its own entirely unique set of properties. To the fun experiment, let's try this. Grab some water from the tap and put it in the freezer. Take a notice of how long it takes for it to completely freeze. Once it has frozen, like this one, set it out in a container and at room temperature and observe again how long it takes for it to completely melt. And then we'll move to the third part of the experiment. With the help of an adult, your teacher or your parent, when they're boiling water, observe as the water turns into steam. Please do not do this alone. Always be supervised by an adult when you're working with it. So try that, and you would have observed the conversion of matter across the three physical states. I hope you find this useful. Tell us which topic you'd like us to discuss next in the comment section. Thank you once again. Please leave a comment, like, share, and subscribe, and see you next time.